Hello everyone, I'm Frank and welcome to Learn How to Sudoku. And where we take a very easy puzzle, a very easy variant Sudoku puzzle, and we break it down in detail so that you can learn how to Sudoku. I don't know, my brain just basically, I just lost my train of thought there. Anyways, today's very easy puzzle is called Thermeven by, I think it's GY77. Or Y77. I'm not sure. Um, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have digits on a thermometer strictly increase as they move away from the bulb. So, for example, we could have something like, say, 269 here, and that would be valid because they are strictly increasing going from the bulb to the tip. What we could not have, though, is something like, say, 769, because it's decreasing from this 7 to the 6 here, and that's not allowed anywhere on these thermometers. And that's an example of how these thermometers work. And finally, we have the digit in the gray square must be even. So we know this is even. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. For these type of thermometers, one can only appear if one is on a thermometer, it can only appear on a bulb. And 9, if it appears on a thermometer cell, can only appear on a tip. Well, this left central box has all the cells which are on a thermometer cell. But we only have one bulb and one tip. So the bulb has to contain the 1, and the tip has to contain the 9. So we know this is 1, 9 as a pair. Column 1 also has something similar, but we have 8 cells that are on the thermometer. So one could be either on the bulb for those for columns 1 and 9, or the empty space. 9 can only be on the tip or the empty space. So in each of these, we have a guaranteed 1 in either one of these two cells. And then we have a guaranteed 9 in one of these two cells. Well, that means one of these has to be 1. And then this can't be 1, so 1 has to be there, which means 9 cannot be here, so 9 has to be there. So the way that this works then is if this is 1 here, obviously you can't have 1 here, you can't have 1 here, but where's the 1 in column 9? It has to be here, which means 9 in column 9 has to be on the tip. That means the 9 can't be here, so the 9 has to be there. So either way, this becomes a 1-9 pair. So the way that columns 1 and 9s work, if this is 1, this can't be 1, this has to be 1, which means 9 has to be there, which makes this 8, 7, 6, 5, 4, 3, and 2. If this is not 1, that means we have to have a 1 here, and 1 has to be there, which makes that 9. So therefore, 9 would have to be there. So if we had 1 here, 9 would have to be here, so 9 would have to be here, which makes this 8, 7, 6, 5, 4, 3, 2, and 1. If this is not 1, 1 has to be there, which makes this not 1. 1 has to be there, which makes that 9. So the 9 has to be there, which makes that 8, 7, 6, 5, 4, 3, 2. And then this would have to be 2. Going down from the 9, it would have to be 8, 7, 6, 5, 4, 3, and 2. So we have these interesting 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, and 8, 9, and 1, 9. pairs. Well, where are the 9s? Maybe I should have just gone down. Yeah. I typically go through every for long thermometers. I usually go from the bulb to the tip, looking at each of the possible going from the bulb to the tip and then looking at the smallest possible digit for each cell, and then going from the tip to the bulb, looking at each possible cell. But in this case, I was curious if I could find another method, but it looks like no. The answer is no. So let's look at these and see what are the possibilities. So these have to be 1 at minimum, which means the next one's 2 at minimum, which makes the next one 3 at minimum, which makes the next one 4 at minimum, which makes the next one 5 at minimum. And then the maximum's 9, 8, 7, 6, and then 5. So these have to be 1 through 5 here on the bulbs. These must be 2 through 6 here on the next cell. Then we have 3 through 7 on the next cell. And we have 4 through 8 in the next cell of those thermometers, and then 5 through 9. Well, that's pretty helpful, because we have a 5-6 pair in row 5, which eliminates 5, 6 in the rest of the row. That gives us a 3, 4, 7 triplet in the rest of row 5, which eliminates 3, 4, and 7 in the rest of row 5, which means we have 1, 2, 8, 9 left. So this can't be 1 or 9 because of 1 or 9 in the box. This 1, 2, 8, 9, 1, 2, 8, 9, 1, 2, 8, 9. Okay. What are some interesting things we cannot have? We cannot have a 6 here, because if this is 6, that forces this to be 7, and it would eliminate all cells possibilities for this cell here. So this cannot be 6 here. We have the same problem here if this is 5. If we have 5 here, that forces this to be 7 to be greater than it. But then the problem with that is this would then be not 5, it's 6. This would not be 6, it would be 7. And we'd have a duplicate in that box. So this cannot be 5 here. This digit must then be smaller than this, so no 4 or 5 there. We have something similar in this right-hand box here. This right central box here. Because this can't be 6, because then that would be 7 here. That would eliminate all possibilities for that cell. This can't be 5. 5 would force this to... And we can't have 4 here either. Right? If we have 4 here, that forces this to be 5, 6, 7, but this must be greater than 4, and it can only be 4, 7 there. So we'd have a duplicate. So this has to be 2 or 3 there. That means this can't be 3. So it's the same thing. This can't be 4 or 5 for the same reasoning. We have a 3, 4 pair in row 3. That eliminates 3 and 4 in the rest of the row. This can't be 5 because, again, it has to be less than that digit. 9 has to be one of these 2 digits, so this can't be 9, which means this can't be 8 here because it has to be less than that. This digit has to be less than 4, 5, 6, or 7, so it can't be 7 there. So this is, we have a 4, 5, 6, 7 quadruplet in this right central box. That eliminates 4, 5, 6, 7 in the rest of the box. So no 4, 5, 6, 7 there. It's 3, which makes that 2, which makes that 1. That eliminates 1 in the rest of the row, 2 in the rest of the row, and 3 in the rest of the row, respectively. 2 eliminates 2 in the rest of the box. This digit is 4, 7, so this digit, and we have a 4, 5, 6, 7 quadruplet in this left central box. That eliminates 4, 5, 6, 7 in the rest of the box. So this can't be 4, 5, 6, 7. It's 8, which means this is not 8, so it's 2. That eliminates 2 there, so it's 3. And 8 can only have 9 greater than it, so that's 9. 2 eliminates 2 in the rest of this row. This digit must be greater than that, so it cannot be 4. This digit must be greater than that, so it cannot be 5. Remaining digits in this right central box are 1, 8, and 9. There's no 1 or 8 here because of 1 or 8 in the row, so that's 9. No 9 here. This makes this a 1, 8 pair. No, 9 has to be one of these two digits. Remaining 1 eliminates 1 here. So this must be 2, which makes this 3, 4, 5, 6, 7, 8, and 9. That leaves that as 1 there. 2 eliminates 2 here, so it's 1, which makes that 2, 3, 4, 5, 6, 7, 8, and that's 9 there. Okay, 5. 4 eliminates 4 in the rest of the box, so that's 7, which means this can't be 7, that's 4, and these digits must be smaller than it. So that makes that 3 and 2 there. 7 and 8 eliminates 7 and 8 here. No 7 and 8 here. This digit must be smaller than that. Cannot be 5, 6, or 7, so this is 4. Okay. Remaining digits of column 8. We have 2 through 7, and these can't be 2, 3, or 4, so where are 2, 3, or 4? They have to be here in column 8, and they have to be in order. Because, so this must be smaller than that, 2, 3, and then 4 there. That means this can't be 2, it's 1. This leaves this as 5, 6, and 7. The only even digit must be in the square, so this must be 6. That leaves us as a 5, 7 pair remaining here. Remaining digits of this upper right-hand box are 8 and 9. Remaining digits of this box or column 7 are 5, 6, and 7. Okay. Remaining digits of row 4 are 6 and 7. No 6 or 7 here because of 6 or 7 in the row. Let's look at these thermometer. This can be 2 at minimum. This can be less, has to be greater than 2, so it's at least 3. This has to be greater than 3, but it can't be 4, so it's at least 5. This is greater than that, so it's at least 6. Cannot be 9 because of 9 in the row, so this is at most 8. This is less than that, at most 7. This is less than that, at most 6. This is less than that, at most 5. So this has to be, cannot be 4 or 3 here, so nothing in between. No 4 here, so this could be 5. This could be 6, and that could be 7. So let's look at this. This could be 3 here. This digit has to be greater than 3, but can't be 4 because of 4 in the column, so it's 5. This is greater than 5, so 6. This is at most 9. This has to be less than that, at most 8, at most 7, at most 6. And this has to be 3, 4, 5, 6. 5, 6, 7, 6, 7, 8, and then 8 or 9. Okay. Where is 3 available in row 1? Cannot be here because of 3 in the box, can't be here because of the way the thermometer works, and can't be here because of 3 in the box. So 3 has to be there. That means this cannot be 3. This digit has to be greater than that, so it can't be 5. This digit is greater than that, so it can't be 6. We have a 5, 6, 7 triplet in row 9, which eliminates 5, 6, and 7 in the rest of the row. So no 7 there, it's 8. No 5 there, it's 2. That leaves the remaining digit as a 3. 8 eliminates 8 here, and it also eliminates 8 there. This digit must be smaller than that one, so it cannot be 7. Okay. We have a 5, 6, 7 triplet in row 1, which eliminates 5, 6, and 7 in the rest of the row. So we are left with 4, 8, and 9. And this cannot be 8 or 9 because of 8 or 9 in the column, so that's 4. This can't be 9 because of 9 in the box, so that's 8, which makes this not 8, it's 9, which makes that 8. Remaining digits of column 3, We have 5 and 6. This can't be 6 because of 6 in the row, so that's 5, which makes that 6. Remaining digits in this upper left-hand box are 6 and 7. No 6 here because of 6 in the row, so that's 7, which makes that 6. Remaining digits in column 2 have to be 4 and 5. Remaining digits in row 2 have to be 1, 4, and 9. No 4 here because of 4 in the column. Remaining digits of row 3, we have 5, 7, 8, but this can't be 8 because of 8 in the column, so 8 has to be here. That eliminates 8 in the rest of the column here. We have a 1, 9 pair now in row 5. That eliminates 1 and 9 in the rest of the row, so no 1 here. It's 8, which means this can't be 8. It's 1. Where is 8 in column 5? Cannot be here or here because of 8's in the boxes, so 8 has to be there, which means this is greater than that, so it has to be 9. 9 eliminates 9 here, so it's 1. No more 1s here. Remaining digits of row 6 are 2 and 5. Where is 3 in row 7? Cannot be here or here because of 3 in the boxes. Can't be here because of 3 in the column, so 3 has to be here. We have a 6, 7 pair in column 6, which eliminates 6 and 7 in the rest of the column. So no 7 here, it's 5. 5 eliminates 5 here, so it's 2 and 5. 5 eliminates 5 here, so it's 6, which makes the 7 to be greater than it. No 6 or 7 there, it's 5, which eliminates 5 here, so it's 6. No 5 or 6 there, it's 7. 7. 6 eliminates 6 here, so it's 7 and 6. 6 eliminates 6 there, so it's 7. That eliminates 7 there, so it's 5 and 7 there. 5 eliminates 5 here, so it's 6. Remaining digits of row 7 are 4 and 5. This can't be 5 because of 5 in the column, so it's 4, which makes that 5, which makes that 4. 4 eliminates 4 here, so it's 9 and 4. 9 eliminates 9 here, so it's 1 and 9. That leaves the remaining digits here as a 2, a 5, and a 1. And that's how you solve it. Yeah, I was hoping to avoid what I usually use for thermometers. But again, it's a very useful technique, and it again shows why. Because it restricts things a lot and it allows you sort of to spot things much easier, right? It allowed us to spot these 4, 5, 6, 7 situations. It allowed us, I mean, essentially we did the same thing, and it allowed us to do, get these like 1, 2, 2, 3, 3, 4, 4, 5, etc. pairs in the columns 1 and 9. It allowed us to get this 3, 4, 7 triplet here. It's a very good technique, and it is what it is. I always try to find something new about thermometers, but I always seem to come back to this because it's just such a useful technique. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.